Welcome to engi17900 Industrial Electronic Devices. So my name is Alan Edge. I'll be the professor for this course. When you need to contact me, please do it through Slate Mail. It's not that I don't read the other mail. The regular mail gets a lot of other business in it, and it has happened that someone has tried to contact me and it just got buried in the wash. I do check Slate on a regular basis, so please use Slate to get in touch with me. Just want to give you a bit of a rundown before Monday and Tuesdays start at 8 o'clock. You are responsible to be on time for each class and sign in. Part of that has to do with the fire code. Once any lecture begins, which will be no later than 10 minutes past the start time, the door is going to remain closed until after the lecture is finished. We don't want to disrupt other people's. The virtual class is set up and accessible through Slate. It'll be on Mondays at 4 p.m. It only lasts an hour. They are recorded. However, it is strongly recommended that you attend and ask a lot of questions. These virtual sessions may include lab overviews so that you'll be prepared for the lab class itself. There'll be also posted videos that run through the labs step by step. Please watch them before the class. A virtual class will be set up, recorded on Family Day, and it will be available to watch. And it may cover some theory, it can give us some catch up, and it might do some review depending on how far along we are in the course and how close we're getting to a quiz or the midterm. Won't be the midterm, it'll probably be closer to a quiz. So your first task prior to our first lab, you must go onto Slate and read over the lab safety, and there's a quiz, the lab safety quiz. You need to have that done by January the 9th. If you don't have it done, you can't participate in the labs. It's not a difficult, most of it is common sense. You must achieve 80% in order to be successful. You'll each be given a complete electronic component kit at the start of the first in-class day. It is recommended that you pick up a small plastic storage container box, preferably not something like a Ziploc ones, but something with a good snapping lock, good snapping lid. Part of it has to keep your parts safe and secure. It's easier to remember, and when you're doing labs, you don't want to keep dumping out your parts because you'll lose them. Not only that, if they fall off the desk, you don't notice it. The little resistors are, well, they're like walking on ball bearings. You get one under your foot, you will slip and fall. So we don't want anything to happen. We want everybody to be safe. And also, if you don't notice it missing and you come back 2 weeks later and you need that particular resistor or diode or part and it's not there, we don't have a lot of spare parts, and there are multiple classes all kind of vying for the same parts. So that in mind, if you lose your kit, you won't be allowed to borrow another person's kit or parts, and you'll have to go and purchase a new kit or purchase the parts that are missing. So by getting yourself a little plastic container, then you'll be able to make sure that you have all the parts, and you can do a quick inventory. I personally was supplying them for a while, and everybody said they would return them at the end of the class, and I think I got 2 back of 4 classes. So you'll have to spend the $1.50 at Dollarama to give yourself your own storage box. I still use my own storage box myself, so it does keep things organized. So this course has 7 marked labs. Every lab requires the same thing. 1, you have to have passed the lab license quiz. If you haven't done that, you can't form the lab. That's simple as that. 2nd, you're to be present in class, signed in and on time. 3, you have to bring your electronics kit. No kit, you can't work. You have to bring your tools and have your safety glasses. You're going to be following electronic drawings and diagrams, and I strongly recommend that you pick yourself up a highlighter of some sort. And whenever I'm doing something like that, and it can be as simple as a diode circuit, Like I'll have the diode on my circuit and I'll just, once I've got it installed, I highlight that I've done it. And I can forget about it and move on to the rest of the circuit. It's not that difficult to do, but it's important to keep track of what it is you're doing. And when you go back and you try to troubleshoot it, you know where you left off. Now, you may be wondering why we have these rules in place about, not being late, having your own kit and all the rest of it. Well, it's quite simple. When you go out in the real world, whether it's construction or industrial environment, you have to show up on time and be ready to work. Simple as that. You have to have your tools, have to have your whatever equipment you require. But the other thing is that the learning outcomes expected of each lab is explained during the lecture prior to starting the lab. And in the past, where people have come and gone when they were pleased, I'm supposed to keep the door closed in case of emergencies, etc. So that means I've got to stop what I'm doing, open the door, disrupt the class, and then pick up where I left off, and people's trains of thought gets lost. And everybody in the classroom has paid tuition. They're all there to get the same satisfactory outcomes. So being late and disruptive doesn't help the learning environment. If you're out working in construction, I worked for 30 years at the Ford Motor Company. We did maintenance and construction within the site. We worked with outside contractors all the time. And anytime there was a project, we would come in on a Saturday morning, for example, nobody picked up a tool until they had a meeting, and it was called the pre-task analysis meeting. And what that basically was is laying out what the jobs are, what the expectations were, and where the material was going to go, who was going to install it, what equipment was being used, whether you had your safety harness. All of that was identified even before the work began. And that was not just Ford employees, that was the contractors doing this. So if you're late and I've already had my lecture started, and you have to wait till the end of the lecture and then you come in, you've not received that pre-task analysis, that learning outcomes that you expect for that particular lab. So since you don't have that, you will likely not have the requisite information to do the lab successfully. So it is absolutely mission critical that you attend every single in-class, and preferably don't try to leave the video till later, because YouTube may have all kinds of stuff. You have to wait weeks. If you have a question you want to answer, you have to wait weeks for the guy to get back to you, if they ever do. Most YouTubers will post something and then never look at it again. And if they get feedback, great, but they don't answer questions. Your opportunity to ask something that you don't understand is on the virtual class and in the lab itself. So even though you can watch a video later on, you won't really have a lot of time because it's the next day. So make a point to be there for the virtual class and make a point to be for the lab class, and be on time. I can't stress that. So the primary focus that we're using on this course is to introduce you to the basic electronic components used throughout the electrical industry. And we're also going to expose you to some of the tools and test equipment you may use. The course is designed to reinforce the electrical theory you have received thus far and give you additional insights and troubleshooting skills. It consists of theory, practice, and hands-on labs. In the labs, you'll be constructing electronic circuits and then testing them. You'll be verifying Ohm's law and Kirchhoff's laws, and you'll get to troubleshoot things like transistors and putting your digital multimeter to use. And part of lab safety, when you're doing these labs, involves keeping your workspace clean and free of distractions as well as clutter. It also means tidying up afterwards and putting things away. So when you come in, your backpack should not be on the workbench. Put your cell phone away in your backpack where it's not going to fall off and get damaged. Put the backpack to the front so that you won't trip on it. If I have to come around and see it, I'm not tripping on it. You know exactly where it is, so it's close to hand. Make sure you bring your tools. Your workstation should look clean and only have the components and your tools on the actual work surface. Later on, we're going to be doing some soldering, and backpacks are usually made of nylons, etc. And nylon melts and burns really quickly. You don't want to accidentally put your backpack, expose it to the hot soldering iron. Small burns one thing, setting it on fire is something else entirely. So you don't have the room and luxury anyway. So if I come by and I find that your work area is unsafe because it's tidy and cluttered, I'm going to ask you to clean it up, and I won't repeat that. I will simply address it accordingly. So make sure that you keep your work area clean. When you're finished, especially when you're working with test leads and hookup wire, etc., there's a rack on the back. They have to be hung up the way you find them, which should be neat and orderly. If I get another professor complaining to me that the class that he replaces me on finds it a mess, I'm not going to be happy. I'm going to be embarrassed, and I'm going to have words. And if it happens more than once, then we'll have to address that, because it's just like working outside of in the real world. They can't work in dirty construction sites that are trip hazards. They don't work when they can't find the equipment. So it's part of your responsibility to put things away properly when you're done. The good news is you're going to be using a bunch of different test bench equipment or tools. This may be, it's quite entirely possible, the only time that you've ever used these. And then again, on the other extreme, as I said, I worked for Ford for a number of years. We had lots of different equipment we needed to test. We worked with the stuff that we're going to be dealing with: analog meters, oscilloscopes, function generators, soldering irons, and power supplies. All of those things were tools that we used. When you had, for example, when I was working at Ford, I worked in the body shop. We had 147 robots at the time. Numbers of robots kept getting more and more, but the ones we had these older amplifier boards, and there was two parts that would burn out. The amplifier board itself had to come from offshore, and they didn't keep very many of them in North America. So if you had a robot go down that's doing a critical job, you did not have the luxury of waiting 6 months to get that board. They had to fix it. We had to troubleshoot it, figure it out, replace the capacitors, replace the IC chip, put it back into service, and get it running as quickly as possible. So you can have both extremes, where this will be your first and only, and then you can get to the, well, you'll also do it in the second level, but after school you'll never see another oscilloscope. And then on the other hand, you could end up in a situation like I did, where you were working with the equipment on a fairly regular basis. You're also going to be working with quite a few electronic components: resistors, diodes, transistors, and integrated circuit chip logic gates. You'll be breadboarding with new circuits, and then you'll be testing them, and there'll be an exercise where you'll be actually soldering some of the components onto a circuit board. And trust me, it will be a very busy but rewarding semester. So that's kind of the 30,000-foot explanation of the course and some of the responsibilities that you have in the class. As I said, there's going to be 7 labs. There hopefully will be a couple of experiential labs as well. Keep your hands busy, keep you involved. And I think you'll find that although the timetable is tight enough as it is, you'll find that you'll be busy through the whole time, and you won't want to be late because of the fact that you'll be busy all the way through. Anyway, I'm here to help you succeed, so we'll see you next week.